Good evening. So this is my host Dennis Kafaras, engineer. I hold a Bachelor of Computer Engineering, second Upper Holmes, and I am an ICT support officer at Afritech Innovation Solutions. I am an embedded systems designer and an Android application developer. And today I want to take you through one of the most important topics in computer science, which is called logic and digital electronics. Very important topic that every computer scientist, every computer engineer must understand, because you have to know how the whole thing works. Digital, analog. You have to know how digital things work, ones and zeros. So I gonna take you, this is the best thing you can have, and I'm gonna take you through this affordable ICT. So now we go straight to the logic gates. Logic gates or gates. I know civil engineers civil engineers are used to their gates, and they open the gate and the cars pass through, but in the computer science we have our own gates. They function the same way like your civil engineering gates, but our gates are different. Okay, so gates are fundamental functions performed by computers and related equipment. A single integrated circuit within a computer contains several gate circuits. Each gate may have several inputs and must have only one output. You get it? One output, but you can have several inputs. And you always hear IC. So I want you to understand, when you go to mechanic and it tells you this is your IC got burned, you know what the IC is talking about. It's talking about an integrated circuit. An integrated circuit is made up of thousands of transistors. So these things I'm related with the aircraft, because I am an aircraft maintenance engineer, electrical and avionics, and now I'm teaching about the electrical guys of the aircraft. So if you as a person, if you want to know about the aircraft, this knowledge is still the same related, because we are applying the computer knowledge to the aircraft, and you are in the right place. So the logic gates, there are 6 commonly used logic gates. We have the AND gate, we have the OR gate, we have the invert, or the NOR gate, and then the AND, and the exclusive OR. The name of each gate represents the function it performs. Here in the computer science, we have what we call truth tables. Truth tables. We don't do false things. You are either true or you're false. There is nothing like I am supporting both sides. That is not there in computer science. You have to be on one side. You are on the losing side or on the winning side. You are either a 1 or a 0. You are true or you're false. So these are systemic means of displaying binary data. Truth tables illustrate the relationship between the logic gates input and output. This type of data display can be used to describe the operation of a gate or an IC. I'm going to give you an example like a switch, a wall switch, your ordinary switch that puts on light and puts it off. It cannot be in the neutral state. I remember in senior 2, we had some students who want to make that switch to be in the neutral state, and they would end up deforming it. And I remember one day we were told to contribute money to buy the switch, and that was something that was very awkward, and and that person has lack of scientific knowledge, knowing that you can either be true or false. It is only the artists who or lawyers who argue and they find to be neutral. No, for us in computer science, you are either right or wrong. Now, for troubleshooting purposes, the truth table for a specific IC is often reviewed in order to determine the correct output signal for a given set of inputs. Each logic state has a symbol of a specific shape. The symbols are designated to point at a given direction. The inputs are always listed on the left of the symbol and the output on the right. Since the logic gates separate using digital data, all input and output signals will be composed of ones and zeros. The symbol 1 represents on of voltage positive and 0 of or voltage negative. When representing logic press operations using Boolean algebra, each value can assume either a true or a false value, and these values are represented by 1 or 0 respectively. When electronic switches are used to perform a logic operation, it becomes necessary to assign two discrete voltage levels that will correspond to the binary digits of 1 and 0. In a logic system where the DC supply voltage is say 5 volts, then two choices for the voltage levels are available to represent the binary states of 1 or 0. These are shown in the diagrams below. Positive 5, it is a 1. Here we have a 0, which is 0 volts. So it is state 0. Positive 5 volts, it is on a logic state of 1. This is the positive logic. It is from 0, it goes to 5, and then it goes back to 1. This is from a 0, goes down to 1, goes down to 0, meaning it is an inverted state. This is the negative logic when you have negative 5 volts. Then we have, as can be seen, that positive logic stimulates that the voltage level assigned to the active state is more positive than the level assigned to the negative state. Of course, it can be seen that the negative logic is the opposite. That is, voltage level assigned to the active state is more negative than the level assigned to the active state. The AND gate. An AND gate can in theory be said consist of only 2 or more switches connected in series. When you have a series circuit, when you switch off one switch, you have disconnected. The circuit is incomplete and you can never have light. So AND gates will only produce a logic 1 output when all inputs are simultaneously at logic 1. Any other input combination results in a logic output. The figure below shows the symbol that represents a 2-input AND gate, which can be produced by 2 switches A and B in series. You get this switch A, switch B, then the lamp and the earth. If this one is open, even if you switch on this one, you will never have light because you're getting the power from here, and if this is open, this one has no power, so you have an open circuit. You have nothing. This is A, B, and we see this is the representation of the AND gate. You have to master how to draw this gate because you have to make it. This gate will only adapt a state at its output terminal when both A and B are in the positive state. That is when all the switches are closed. Sorry. So you can see the truth table. So, AND gate. So if you have two conditions that must be true for that thing to be true, if that is called an AND gate situation. As we proceed further, the truth table will sometimes become quite complex, especially when more than two inputs are used. The OR gate, it produces a logic 1 output whenever any one or more inputs are at logic 1. Putting this in another way, an OR gate will only produce a logic 0 output whenever all of its inputs are simultaneously at logic 0. So for the OR gate, it will be true as long as one of those inputs is true. We have it is symbolized by a plus. Actually, the AND gate is more like multiplication. When you have 0 times anything, it will always be false. It will always be 0. Now here, if you have 1 plus a 0, you have a true answer. And we draw it like this. You practice how to draw it. This is the OR gate symbol. A, B. We have this condition when A is a 0 and B is a 0. Automatically the output is a 0. When A is a 0 and B is 1, that means 1. When A is 1 and B is a 0, when all of them are true, then you have true. We have the NOT gate. It has 1 input A and 1 output, which is the inverse of the input. This function in Boolean algebra form is a NOT. You put a NOT here. Since there is only 1 input, the number of outputs possible is 2, and the NOT gate truth table shown below. If it is a 0, you invert, you get a 1. And you see the symbol. If it is a 1, you invert, you get a 0. Now, we have what we call the Morgan's laws. This man called De Morgan designed these things, and this thing is called mathematics of computer engineers or scientists. This mathematics is not your ordinary mathematics of the civil or mechanical engineers. No, this is for computer engineers. We have A plus B, which are inverted. You get A inverted times B inverted. A and times B inverted. You separate them. This and changes to a plus, and these ones maintain the inversion. You can see how it changes. If you have an O, you have an OR gate inputs and you invert them. Then those inputs will become inverted and be fed in an AND gate. That is the equivalent. If you have an AND gate and you put an inverter, those inputs will be like they are inverted and they are fed into an OR gate. We have the exclusive OR logic. This exclusive OR will produce a logic 1 output whenever one of the two is at logic 1 and the other is at logic 0. So here, if you have both of them being true, then the thing is false. Exclusively for men. There is a story I had. This guy went and bought a shirt and it was actually said exclusively for men, which means that thing did not belong to men. It belonged to women. So when both are logic 0 or both are at logic 1, this will produce a 0 whenever both the inputs have the same logic state. This is the similar in life. If you find a man who marries a wife and they are both very short-tempered, automatically that marriage will not work, because two short-tempered people cannot make a marriage. It has to either be one of them to be short-tempered and one of them to be forgiving, so that the marriage will be true. Inverted inputs and outputs. We have the NAND gate, where we have the NOT AND. We have an AND gate that is noted inverted. We can see the truth table for it. In this gate, when A is 0 and B is 0, then the output is 1, because we see A as 0, 0. The input in as the AND gate, it is supposed to be 0, because it is passing through this NOT, it is going to be a 1. An AND gate, when you feed it with 1 and a 0, it will give a 0, and that means you invert it, you get a 1. We go to the NOR logic. Not all. We have the OR gate with a NOT. You see this thing? If you get a NOT gate, you have A or B. This thing is supposed to produce a 0. If you invert it, you get a 1. A or 1 is supposed to produce a 1. You invert it, you get a 0. It is supposed to produce a 1 when those inputs are both 0. That is, will produce a logic 1 when all the inputs are simultaneous at logic 0. A NOR gate is simply an OR gate with all its output inverted. I think you can say the NAND gate is an inverted AND gate. I think we can stop there. Next time we shall look at sequential logic circuits. God bless you and peace be with you. Don't forget to subscribe to our channel. And this is Mohos Dennis, your engineer tech.